Hello, and welcome to another episode of Real World Analytics, or What Schools Don't Teach You. This is another installment of my Kaggle series, where I'm participating in my second ever Kaggle competition, and in particular this one I've split into two parts. In the first part I tried to be more technical, and I used a support vector machine for this regression problem, but today I'm talking about kind of the second half, which is a more business-focused approach to this Kaggle competition. And so the problem statement technically is still the same, that you're trying to build a regression model, you're trying to predict house prices, but I want to go into some of the nuances that you might encounter in an actual engagement. So I asked for volunteers, and a colleague reached out. He works for a bank, he's interested in predicting house prices, but rather than just say, okay, let's minimize the root mean squared error and get on with it, I first wanted to talk to him about the different aspects of the problem and why it mattered to him. And the first thing he said was, this is a little different to your kind of standard, you just go for it. You've got your realized price, you've got your independent variables, and you make a prediction and you compare it to the realized. The first problem was they don't always have realized prices. And you might think, well, what do you mean if you're making this prediction? If you don't have a realized, what are you comparing it to? And this was precisely the point, because if you're looking to refinance your mortgage, if you want to top up or you want a home equity loan or something, the bank hopes that you don't get a sale price. So if I have a mortgage and I want to borrow $50,000 in order to redo the house, redo the kitchen, what have you, the bank prefers that I get the loan, I redo the kitchen, and then I just go back to paying my mortgage, that I don't actually sell my house. So immediately we have this problem that if you don't have a realized value, then I don't know what to compare my output to. And what becomes important is that not that my model is accurate, but that it's perceived as accurate. And I was talking to him and he was discussing their current model, and they were very happy with the model, but the frontline people would keep having a professional valuation done. So then they'd have to call an appraiser, you'd have to pay for the appraisal, it would take some time for the appraisal to get done, and so there was a delay in responses to the customer, as well as an incurred cost. But they have a model, but for whatever reason, the frontline people weren't using it. And so I asked him, I said, well, so is the problem your model, or is your problem the communication about the model? And there was a pause for a moment, and he's like, yeah, okay, maybe the people just don't understand the model. And I'm thinking back to the support vector machine that I wrote in the earlier incarnation, and unless your plan is just to blind the frontline staff with science, I don't see using a support vector machine is going to help win over people. Secondly, if I think about all the variables that are coming through in the model, a lot of them have to do with conditions or qualities. And if you're not trained in how to assess the condition of the roofing, for instance, it's not going to be easy to enter something. Either everything's average, or if I'm being cynical, if someone wants the loan approved, they're more likely just to call everything excellent. So I was going through what he was saying and trying to constrain myself in terms of algorithms. So it needs to be explainable. It needs to be something that the frontline staff feel that they can own. And it needs to be something that I can generate quickly and without some of these other variables like conditions and qualities. And because a frontline staff is going to be typing all this information in, I don't want to give it all 80-some variables that were in the initial data set anyway. So I was looking through various options, and I found the party kit package, which allows me to combine decision trees and linear regression into one. I'll put up an example of an outcome, and I'm able to do this down by every neighborhood. So every neighborhood gets their kind of hybrid decision tree linear model output. And there's another advantage to doing this for a business client rather than Kaggle, and that is I could ignore certain aspects. Like what, you ask? Well, for some neighborhoods, there's not too many data points. I think one neighborhood has 2 data points in the data set, and rather than being forced to come up with an estimate for some new value in there, I can say, well, look, if someone comes in from this neighborhood, you're going to have to default back to the original process and get a professional appraisal done. Sorry, but we just don't have enough data to support this type of automated. And if you come clean with people that, look, we have these gaps in the data, we have some areas where we don't actually feel comfortable making a prediction, in my experience, you end up with a more positive kind of impression of the model, that you acknowledge the shortcomings and you just say, go back to the current state for those, and everything that we do have enough, let's actually try to save some costs. So that was largely my experience there and how I'm going to be constrained going forward. I'm now writing all this up. I'm using the same basic template I did in my technical one. Again, if you want more information in the technical one, I'll be linking it shortly. But I'd like to hear more from other people about these types of engagements, that what types of constraints are put on you, in addition to just, hey, we want a regression for house prices. This is kind of the point of the channel, is what are these real world constraints, these real world special cases that make it different from a Kaggle competition. One of my main criticisms of Kaggle is you don't have this type of business engagement, that there's no sponsor from Kaggle that I can write questions to or that can further help guide what's appropriate and what's not and make it less of a science topic. So that's all for now. Thank you very much for watching. Please do let me know in the comments down below if you ever have anything like this, and I'll see you next time on Real World Analytics, or What Schools Don't Teach You. Goodbye.